whose mean is 0 as well as the whose power spectral density is two-sided one, that is n naught by 2. So if we look into that is PSD diagram of a white Gaussian noise is n naught by 2 for all frequencies. This is Sn of f. Here the filter transfer function is given in the question itself, that is this is located about the some center frequency and whose bandwidth is to be on both the sides, it is 1. This is H1 of f. This is a band pass filter. Comes to H2 of f, which is a low pass filter whose bandwidth is similar to that one, that is 2b, and the magnitude is 1 over the desired frequency range. Now suppose I am assuming this is S1f, this is S2 of f. So S2 of f is equals to 1 by 2 S1 of f plus fc plus S1 of f minus fc. So if we plot this function, that is S2 of f, we will get this as n naught by 2. This is 2fc minus 2fc. This magnitude is n naught by 4. This magnitude is n naught by 4. So after passing S2 of f through a low pass filter, that is output Sn of f, that is nothing but this is 2b, that is minus b2 plus b, magnitude is n naught by 2. Here the time domain equation is, that is n of t is equals to minus b2b n naught by 2 minus j2 pi ft df, which is nothing but n naught by 2 e power minus j2 pi bt minus e power minus plus j2 pi bt divided by minus, this is plus, so j2 pi t. So if we solve this one, n naught by pi t to sine of 2 pi bt by, so this is 2 pi b, here b t, this is 1 by 4, okay, not 2, see 1 by 4, so we will get again these two, so n naught b divided by 2 sinc of 2 pi bt, that is option B is correct. For the following program, the accumulator contains is 10H before executing this particular program. So what will be the accumulator content after the execution of pop instruction, which is located at 2007H? So first of all, what do you mean by PSW? We have to know. PSW is nothing but a 16-bit resistor whose higher order byte is nothing but an accumulator, whose lower order byte is nothing but a flag resistor. So before pop PSW, we are pushing the contents of B into the stack, top locations of the stack, that is 20 FF and 20 FE 0100. So pop PSW means this is 00, this is 01. So pop PSW means the lower order byte is loaded into the flag and higher order byte is loaded into the accumulator. So the accumulator content after execution of this particular instruction is going to be 00. That is option B is correct. So what are the stack pointer contains after the execution of the call instruction? So here before call instruction we are performing one time push B as well as 2000 at location 2007 we are performing pop PSW. So these two are exactly opposite operation, so stack pointer is not going to be affected because in case of push B it is decremented by 2, in case of pop it is incremented by twice. So while performing the call 2064 instruction, it stores the next location address, that is 200E, into the top two locations of the stack. That means the stack pointer address is incremented by, here this is 200E. So now the location address is 20FE, that is option B is correct. It is shown in figure. Given omega as 5000 radians per second, construct the admittance locus diagram. So if we look into this one, the total admittance is nothing but the admittance of this branch is y1, admittance of this branch is y2. So yt is nothing but y1 plus y2, which is 0.417 minus j.0188 plus 1 by 4 minus jxc. So if we plot, y is nothing but conductance plus jb, that is susceptance. So here this is going to be minus j.0188, this is 0.417, this is the y1. Here whenever xc is infinite, so this is 0, xc is 0 means 0.25. So it is kind of a semicircle. Here this point is xc is 0, this is xc is infinite. That means xc is going to be 0 whenever c is infinite. This is c is 0. That is, this is the correct admittance locus diagram for the given network. Find the capacitance values for which resonance occurs. Here at the value of resonance, the admittance is going to be purely real. So means the imaginary part is going to be 0. If we make the imaginary part is equals to 0 in the above given admittance equation y of t, we will get xc square minus 11.36 xc plus 16 is equals to 0. So if we solve this quadratic equation, we will get xc as two values, that is 9.71 ohms, 1.65 ohms. So we know omega equals to 5000 radians per second. Xc is nothing but 1 by omega c. Here C1 is 20.6 microfarad, C2 is 121 microfarad. That is option both A and B. That is option D is correct.